Hello, my name is Matthias Hauck. Today I want to show how to realize multimodal workloads with SAP HANA Cloud. In this demo, I want to show how to preprocess point of interest in the context of London, how to use them to create analysis related to street networks. The demo is related to typical problems that are in the area of utility networks. So you see this when you, for example, work with power grids or so on, or sewer networks. Okay. Typically, when you work with road networks, you have information about road junctions that represent vertices and edges. In practice, there's often a third category of data. These are point of interests. Point of interests can be, for example, museums, clinics, or pubs. Many data sources that provide them in the form of JSON data, and they are have flexible schema depending on the data that they represent. For example, a pub has a name, while a wastebasket only indicates where it is. Yeah. To handle this JSON data, HANA has an integrated doc store, and it can also be used to be combined with other data. For example, it's possible to join it with tables. So here I've joined a collection of JSON data with some special information. In the context of graphs, the problem is quite often that they are not attached. This point of interest data is not connected to a graph, so there needs to be additional preprocessing steps. What turned out to be a quite good approach are so-called Voronoi cells. Voronoi cells, they are derived from a set of points, and each Voronoi cell represents actually the area of influence where each point in the Voronoi cell to a given reference vertex point is it's the shortest in comparison to others. What we can do now is we can actually compute for all street junctions in our street networks a Voronoi cell, and actually then we know which point of interest fit into this Voronoi cell, and actually we can use this to snap the point of interest to our street network. Yeah, I've done it. I had compute for this for the clinics. I had snapped the clinics to Voronoi sets, and here, for example, here we have the clinic is located here, and this is the Voronoi cell actually it belongs to, and this is the street network point where where it belongs. So we can now combine our point of interest data and with the graph. Next step is actually to create the graph. Here we create our graph workspace. This is a graph workspace that represents simply the street network. In a recent version of HANA, we introduced that we can generate a graph workspace based on multiple edge and vertex tables that have also an optional label. For example, we could here also add the tube network so that we actually combine the street and the tube network to do an analysis based on both. Okay, now we have our graph. The next step is actually to perform an analysis. And what we could do is we could, for example, analysis what how long it takes, for example, for a person to go to the next hospital. And what we can do here is create an isochrone map. Here we select our points of interest, for example, here the clinics. We calculate drive distances and then select what's the minimum drive distance for on all of the point of interest we start from. And then we can do some spatial clustering on it to get our map. How does it look like in HANA? What we do here is we have our a graph script that does it. It is based on a short call of shortest path one to all with a custom weight function. What this weight function does is it calculates based on the edge data, the length, and the speed that can move on this road segment. And yeah, so this way we actually compute the runtime. We have also an upper bound, so we ignore road segments that are out. They are not important.
3 more minutes.
Okay. What we can do now is we can actually compute for every clinic the time to all other road segments. We can also join it with the point of interest data, because these are all accessible in HANA. And here, for example, we can see where the next telephone from the first skin clinic is, or the next bench. Okay, but in the end, we want to do calculate our isochrones. What we do now is actually we run SQL query that execute for this graph query for every clinic. Then it combines them the data with a window function, and later on it does some spatial clustering. Okay, and we can this way we get the isochrones this here, and we can also color code them and visualize them. And then we get this map. In this map, the blue areas actually, they represent short time to the next distance, and the red ones or yellow ones, they represent a longer time. And when a city planner looks at this map, he could identify that in London might be a good place to create a hospital at some Royal Albert Hall. Thank you for your attention.
Thanks, Matthias. Interesting map at the Royal Albert Hall. So are there questions? Yeah, to build a clinic there. Are there questions on your presentation from the LDBC TUC audience? So in the meantime, if while people are thinking about these questions,
I have a question.
Oh, you have a question?
Yeah, actually, it's more like a brainstorming idea. Did you experiment anything with the graph-based JSON data formats like JSON-LD, or there was another one called PG JSON for property graph? I don't know if it's kind of standardized, but since you have a document store, it might make sense to try to rely on some document data that already encodes the graph. Or is it a good idea? I don't know. Maybe it's not. Feel free.
Actually, building graph on document stores, it is a quite natural thing to do. Currently, we don't support it.
Encode the graph automatically. They are meant to be to have a standardized memory representation that is the graph. So I was wondering if you were experimenting or if it sounds like a good idea.
No, we didn't experiment with it.
I understand this just to run on HANA, but HANA has this support for JSON.
Yeah, that's why I'm.
But it's not with that. HANA would not really be a document store in my reckoning.
Okay.
Anyway, so so in HANA you have this graph script language. We saw some snippets of that. It does remind a bit of SQL PGQ in the sense that you have graphs as views over tables. So how is this evolving? Is GraphScript evolving into SQL PGQ, or what can we expect?
Actually, I don't think this is an accident that they look quite similar, because Markus Paradis, I think he was involved with it, and he was also a long time with SAP. But there are no plans to involve it in PGQL.
Okay.
I've read also that I've read also that you have like using OpenCipher somehow in SAP HANA. Is this like still working?
Yes, it's still working. There are OpenCipher tables. You can actually embed OpenCipher statements inside of SQL statements.
Okay.
Oh, great.
Anyway, Matthias, thanks for your demo and your talk. The demo gods were favorable time, and so but we do have to move to the next talk.